Okay, this is Moser walking you through practice problem 5E. This is conservation of mechanical energy. So here's the neat thing that knowing that mechanical energy is generally conserved allows us to do. It allows us to say that the mechanical energy final has to be equal to the mechanical energy initial. And we know that mechanical energy is comprised of two parts. It is the gravitational potential energy and, it's the potential energy and the kinetic energy. So the final, and we're talking about gravitational here, the final gravitational potential energy and the final kinetic energy has to equal the sum of the initial gravitational potential energy and the initial kinetic energy. This is cool because very often it allows us to zero out one or more things. So in the practice problem, we have a child who is starting from rest, that's convenient, and going down a slide, and the slide, we're told, is 3.0 meters high. The kid has a mass of 25.0 kilograms, and what we want to know is her velocity at the end of the slide. Now, prior to this, using all sorts of motion on two-dimension kind of things, you would have to look at all sorts of interesting things. Well, conservation of mechanical energy makes this really, really easy. Watch. We know that her final potential gravitational energy, we're going to assume that she lands on the ground. So her final potential gravitational energy is her mass times gravity times her final height. Well, that final height, h final, equals 0. So lo and behold, that goes away. Her final kinetic energy, we know, is 1/2 her mass times her final velocity squared. Okay, well that's good. We're going to need that because we're going to be looking for final velocity. Okay, so what's her initial potential gravitational energy? Well, it's mass times gravity times her initial height. Yes, she does have an initial height. We know her mass and we know acceleration due to gravity. Great. Plus her initial kinetic energy. Well, we were told that she was starting from rest, mvi squared, which means that that goes away. So what we're left with, yes, it really is that easy, is that 1/2 mass final velocity squared is equal to mass gravity initial height. Cool. Now all we have to do is solve for final velocity, and we've got it. Final velocity equals the square root of 2 times mass gravity initial height divided by mass, which means that goes away. It gets even easier. Her final velocity should be equal to 2 times gravity times her initial height, and take the square root. Okay, that gets us a final velocity raw answer of 7.67202711, etc. meters per second, with sig figs, of which we have 3. We make this 7.67 meters per second. That's it. These are really easy. You're going to like them. And so all of the 5E practice problems are assigned. Have fun.